Hello YouTube. Just wanted to show you a TV that I just recently fixed. It's a Samsung Plasma 59-inch that you see in front of me here. It was left on the curb by a neighbor, and when I asked, I happened to drive by, the neighbor was in the garage, and I asked what was going on. She told me it just fails to power on, and that was the end of that. So I figured, they probably were looking for a new TV anyway because of some sales on, and the costs are now pretty low. I think you can get 60-inch and up, for $300-400, and they don't make plasmas anymore. This is a Samsung, and I'm sure the cost to repair this would have been prohibitive and just not worth the hassle for a professional repair by a shop, even if they did repair it, or either that or finding the board to fix this thing would have been impossible. So having done some previous repairs, I decided to check out what I could gather from either the internet, EEV blog, and Shop Jimmy, and see if there was some way I can repair this thing. Just as an aside, this is my old TV from 2007. You can see it's about a 42-inch Samsung, and this is the new one from circa 2012, I believe. So it's a little bit newer and a lot bigger, at least compared to our old one there. So let me just see if I can find information about this on the back. Here's the relevant info. I'll see if I can zoom in there. Okay. Y404, that's the serial number and model code. Basically, it's a well-known plasma from that era. Not a high-end one. I think it's only 780 or 720p, sorry, not 1080. But regardless, has a nice image. And it wouldn't turn on at all. So I'm going to show you in this video various pictures of the board and the parts that I ended up replacing. My older TV here is also, I changed the capacitors on the board. And you can see here, that's the info related to that one. So that's CN06. Not sure, it doesn't correspond necessarily to the year. It could have been made in 2006, 2007. So this TV's been going on for a while now. But since I fixed it, it seems to be okay for now. Occasionally I do get audio problems. This was the first video I put on YouTube. Fixing this Samsung that you see hanging on the wall, and it usually works. Occasionally when you turn it on, the sound doesn't work, so you just let it cool off and reboot it, and then it will come back to life. It's probably a cap somewhere on an audio amplifier board that I have to go in there and change, but I haven't bothered yet to do it since it's sporadic. And now I might just leave it off and basically rely on this one for my main imaging viewing. So just I'll go ahead and show you the repair video, and then we'll come back to this one and I'll show you some image examples.
Okay, I'm going to show you the process by which I repaired this TV and how I came about getting it. So Samsung 59-inch plasma repair. Let me just go through the slides here. This is the model code, serial number and version. It's roughly from around 2011. I'll show you some specs on that. Basically, it's got a dynamic contrast ratio of about 10 million to 1. Pretty fast refresh rate. It's 1080p. I inadvertently mentioned something like 720 just a bit earlier, or in the conclusion. So it's actually 1080p. You can ignore the 720, and it's full HD 3D capable as well, and theater sound. So I'm just going to switch over here to flip over to some of the specs here. So this is from CNET, and what you can see here, it's talking about the 2011 plasma shippings, planned shipping, the lineup. So if you slide down here, that's as of August 16th, 2011. We'll scroll down here to the P plasma series. So we have not the PN, I believe those are, I'm not sure what the PN are, but they look like smaller TVs. The PD, where is the PD? Here we are. No, PN. I had it here. Hold on a second. We will find it. PN. Here. PN 59D 550. And that's the TV we have. Okay, the 759 inch. It's available March 2012 maybe. I'm not sure, because they're calling them 2011 plasmas. So does that mean they're coming out in 2011, because this article is actually updated August, so maybe it is 2011. Anyway, original retail price was $18.99. So that's about eight years ago, I would say. Maybe people buying it on sale, maybe 7-8 years ago, on the season ending. But that's about the price of plasmas back then. Obviously, it's gone a lot lower now. Plasmas are no longer available, but starting LEDs and LCDs, well, they're in the 500-600 range for this kind of size. So it's no wonder people don't bother repairing anything anymore. Let's look at the specs. I believe I have here some specs. So there's Plasma TV Series 5, 59-inch plasma, full HD 3D picture performance, narrow bezel with 1-inch larger screen. So it looks very sleek, very sleek. Here, just lots of impressive, maybe by those days, specs. But I mean, all in all, it's a nice TV. It's a nice TV. Certainly, it should last a while. It shouldn't be something that should be garbaged after only a few years. But in any case, let me shut this down, and I'll close this screen as well. Okay, and we'll head over to the presentation again. So now, keep in mind, I didn't know any of this when I picked up the TV. I just saw a TV laying out on the curb, and I asked the person who happened just to be outside in their garage at the time, what's wrong with the TV, and if I could take it. And they said, it's broken, it won't turn on, take it. So I took it. And then when I picked it up, I realized it was heavier than I remember TVs being. But then again, it was larger than any other TV I've ever picked up. I didn't actually realize that it was a plasma until after I looked up the part number and I started to get a hint from the size and the sort of the look and feel of the TV. Okay, now, why do I pick it up? Because I fixed TVs in the past, and it really upsets me that a lot of people dump these things when simple repairs can prolong their life. A lot of my own Samsung 42-inch, I have a video of. It's actually my first YouTube video. It died roughly about 2.5 years into use, and at the time, Samsung was denying any wrongdoing. Eventually, they got sued, and there was a class action lawsuit in the U.S. Somehow, it became a popular search term, and the YouTube video that I did on repairing my Samsung gained quite a few viewerships. So, and it was really just a simple cap replacement on the power supply. So it was $3-4 fix to save a TV that at the time probably was close to $1,000, dying after 2.5 years, which is a shame. And we want to try to avoid electronic waste. As you can see here, it's really a disaster, and we can minimize a lot of this if we just put a little bit of time and effort into learning how to do some basic troubleshooting and seeing if you can repair your stuff. So I opened up the TV, not knowing what I'd find. I was hoping and praying that it was a cap problem, because that's a common issue, and it's a pretty easy fix and cheap and also easy to find caps at a local shop. So I opened it up, and inspecting the board right away, you could see. I'll bring up my mouse here. You can see here, right in the corner, there's some brown sort of markings on this white band. The rest of the, looking at the board, we're going to inspect it later, but I didn't see anything really obvious. I was trying to look for some part numbers, just seeing what I could come up with. Nothing there of interest. Just looking down the caps, no bulges, no leaky stuff. I mean, they look all in good order. All of these transistors and power transistors and such that you see along this heatsink look pretty good. Then I went off to the other side and I noticed these two capacitors in blue looked burned, and that brown mark. So it was actually fried. These things were fried, and you can even see on the silicone there's this brown marking. Right in this section, here I'll go back for a second, I also happened to find the board's part number, because there's a few different numbers on the board, but this is the actual board part, and there's a little mark by the A, so you don't see the rest of it, but it actually says BN 44-00445A, and so that's the board that I was basically looking to replace or repair. So there it is. I'll zoom in a little closer. Now I had to remove that silicone because it was covering up everything. There were resistors under there. Once I took out a multimeter and started to check out all these components in this area to see what was going on. I found both capacitors looked like they were pretty much toast, and there's a FET behind them there that you can see covered in that silicone stuff, which also tends to go as well, which I found out using further research and some YouTube stuff I'll show you in a moment. But yeah, you can see how badly those capacitors were chewed up. But you don't just change the stuff that looks like it's chewed up. There's a lot of stuff on the board that can also fail along the way. The capacitors may only be a symptom of another underlying issue. Now, I go to these sources usually when I have a problem, and anyone who wants to learn about repairing their electronics should really, get acquainted with these. EV Blog has a wonderful forum there that has many hobbyists and professionals that like to help people repair, and they provide very valuable information and a lot of advice and tips. So definitely go there. The other thing is YouTube. Thankfully, there were some helpful videos on YouTube. NorCal715, I want to thank for putting up actually a video exactly on this board, and even pointing out some of the components and some tips on how to troubleshoot. I'll show you some of that in a moment. And the other site which I typically go to is Shop Jimmy. I've bought stuff from them before. Usually they will sell component kits and actual boards for repairing TVs, and so it's good to have them around. Definitely a good place to shop for any electronic components. And then finally, I try to find schematics on the web if I can, just so I understand the problem better. Not that I'm going to be professionally reading every schematic and understanding it, but it helps to see parts that are associated with each other and what to expect as far as where you should troubleshoot and look for other problems. As if, say, a part gets shorted, then it allows higher currents through another part downstream or upstream of it, and you can kind of trace issues. So it's good to get schematics available. I couldn't actually find the schematic for my board, which was version A. The closest I got was version C, which is shown here. But and unfortunately, it was not exactly a copy of my board, so it didn't help me a lot. Anyway, I ended up removing the components. You can see the very badly damaged caps at the bottom. Well, one is completely shredded to pieces. The other one's just got its brother's ashes on it, essentially. But I took those out. I ended up taking out also those FETs because of suggestions that they also commonly fail. And I tried to test them out with the multimeter. It did not get good results on the leads. So I don't think they were in good shape anyway, and component repair kits all include these anyway, and I knew I was going to buy a component repair kit. there's a reason for it, because component repair kits usually will give you the few components of the board that typically fail, and so that's going to be the most common stuff that's going to go, and so they just want to cover the bases, and will give you a small set of parts that usually once you replace will tend to bring your board back to life. So that's the soldered. You can see a little bit of that silicone still left there, which was a real pain to get rid of. Apparently, from what I understand, the silicone's there because these FETs attract dust. The leads, once they have dust, especially in environments that have ash, like fireplaces or candle burning, you get carbonized dust material deposits, and the static from the FETs attract to the leads, and it shorts the leads, so that can damage your FETs. But it can also, you'll notice that on other areas of the board they didn't use it, so I'm not sure, how they selected what to put where, and why they ended up covering those resistors with the stuff too. It was like a lot of material. Next to, on the other side of those FETs that I removed, you can see a small chain of components here that are downstream to it, or upstream, I'm not sure. On the schematic they're lower than the FETs. And what you do is, there's a bunch of little surface mount resistors, so you can easily check the resistance to make sure none of them are blown or shorted, and you can also check those transistors as well to make sure, or their diodes, you can check the diode drops on those, just to make sure that there's nothing that perhaps that's having an issue there. Okay, let's keep going. That's its pair. So if you go back here, you'll notice, okay, there's two, and then that's its pair here. Okay, so those resistors there, and then those resistors there, and you can see that it's QP802, and the other one was QP804. Okay, and the two capacitors were at positions, you can kind of make it out there, CP816 and CP817. Anyway, we'll get to see that in a moment. Okay, so moving on, just inspecting the board carefully, looking for any other problems. These are pictures of my board specifically. You can see some of that silicone material on other areas. Not all the components were covered though. This one was really covered. The capacitors all looked in good nick. I wasn't really concerned too much about the other components because all the repair kits that I looked up for this board did not include capacitors, at least these other ones. They only included these two here, that's CP817, 816, and these FETs on this heatsink. So, and there are a few other surface mount components and a couple of processors, but nothing else. Okay, and they also included fuses, by the way. So, my fuses were fine, both of them. There's one here, and there was another one over here. Okay, they were both fine. So I just ended up removing the two blue capacitors here. Oh, now you can see my board version right there. It's pretty clear. And the two FETs at positions QP802 and 804, I believe. Okay, there's the back side. Okay, nothing really too unusual here. You can go around the board, just look for bad joints. Some people recommend just going over some of these joints, and if they're not looking, sometimes they crack, and there's like a little ring around it. You can look under magnification and try to just solder them again, get that to flow better and fill in. Especially with some of the heavier components, there may be some weight or vibration and heating that will expand and contract the joints on the transformers and such. Okay, so I went through. This is now Shop Jimmy. Their site has nice pictures of all the components, which is great to compare to your own board. There's the back side of the board. Again, you can zoom in on their images and you'll see part numbers, the component locations on the board. And that's the Shop Jimmy component kit. Now let me just show you the website here. This is the website. I wanted to actually, so they have a couple options. One is to buy the board, which is about $84, and then the component kit's about $18. So if you go here to the board, they're out of it right now, but then they suggest the component kit. So I went to the component kit, and there it is there. It's including those two capacitors that you saw blown, and there's this component here which I couldn't find on my board for some reason, and in any case, there's 4 of these transistors, the 2 fuses, and a couple of chips, basically. And the chips I did not change, neither did I change the fuses. So I only changed what you see there, basically being the those components that I showed you earlier. In this area in the top right corner, or sorry, left corner. Okay. Anyway, that's the component kit. This is what I got a few days later by mail. The 2 capacitors that are blue here, and these 2 here, QP802 and 804, which I ended up changing. I didn't actually end up using any of the other components because I tested them as well as I could. I tested out QS802 and 804, and they tested fine on the board. I got diode drops, between the leads, which made sense. Whereas on QP802 and 804, I got basically nothing. They were open. I couldn't get anything on them. And then I was pretty sure that the chips were not an issue, and if I knew the fuses were fine too because I tested them. But also, it's a real pain to try to change those chips. I mean, that's a tough soldering job. So if I didn't, I tried to just see if I could repair the TV, replacing what was most obvious and leaving the rest alone. Okay, so again, just going through the little bags of components. That's one of the chips that I would have had to replace, which was not going to be easy. And just some close-ups there. That was the other chip that I would have had to replace, which again, I really dreaded having to do that. It would have not been easy. Okay, I tried to get a picture of the part number. That's what I got. And let me just show you then one other thing on Google, on YouTube. So when I went to search, this is the gentleman, NorCal715, who came up, and you can see here his video. He's showing that area exactly that failed on my board, right? And all that silicone stuff that's around everything. So this gentleman has repaired a lot of TVs. He was going around the board and basically recommending to look at various things. He was showing that area there, which can crack. You see the ring there? Here, I'll just zoom in. So anyway, not to review his video, but definitely check it out. But yeah, all of these things he went over, and he was telling us how to check over the values of the resistors there on those components. And those are the 2 MOSFETs that were removed, and how to check those as well. You see, with the leads, to check for diode voltage drops. So I basically followed as much as I could the instructions that were in this video, and replaced the parts according to the recommendations that were in this video, and it turned out to be successful. Now let me just close that now and head back. So those are the 2 MOSFETs now changed, and the 2 caps now changed. I did not silicone things back, at least not yet. I'm not sure if I want to. I'm not too worried about dust collecting and forming bridges across here. I'll have to maybe inspect the TV periodically and see if it's an issue, and then I might silicone it. But I have a feeling that silicone stuff may do more harm than good. My soldering job isn't great. I kind of put a huge bead on this thing, which I probably didn't need. You can see on the back side, not the greatest soldering, but it's as good as I could do. And there's the other side, and those are my caps at CP 816 and 817 having been replaced. And there's the board back on the TV. Okay, you can see my new capacitors there, and just demonstrating that it worked. So that's the TV in the garage where I repaired and assembled it back, and you can see it's up and running, functional, and doing very well. So we'll conclude with the rest of the conclusion of the video.
Okay, so now that you've seen the repair I went through, you can have a look here at I put up EEV blog because that's one of my favorite channels to watch, and I get a lot of advice from the folks over there on how to repair TVs and other things around the house. So I definitely recommend, if you are into electronics or want to learn a bit more, definitely listen to this channel and go ahead and join up the forums and learn, because there's so much waste in electronics these days, where simple repairs can fix things. And even if you can't repair it, you'll be surprised at how many simple troubleshooting things you can figure out just by learning some basics. And also safety, which is important. Okay. Again, thanks for watching. Hope you enjoyed this video. Hopefully it inspired a few of you to fix your own TVs rather than dump them. One of the things I did hear from a number of people online was that plasmas are no longer being made, but they do have quite good image quality relative to some of the newer LCD and LED TVs. So they're not quite obsolete yet. Burn-in usually has been mitigated these days because there's a lot of screensaver features. This particular Samsung TV has a screensaver feature, which will see if the image is not changing, it will go into some kind of a mode that will prevent burn-in. You can basically calibrate the TVs for your particular environment, so you can limit the amount of brightness and burn-in as well. So if they're treated well, these TVs should be able to last many useful years. This TV, having been built around 2012-ish, now it's 2019, so it's about 6-7 years old. Really is not a very long time, and there's no reason for it to be dumped only 5, 6, 7 years into its life. However, the only thing, as you saw in the video, was a few spots on the power supply that burned up and were fixed by a relatively inexpensive kit. So, but unfortunately, TVs are getting so cheap nowadays that it's not worth repairing for most people. And as more and more large TVs are being made and they're lighter, and they are reaching the image quality of plasmas already and maybe surpassing them, I don't think we're gonna be repairing too many of these TVs anymore. But if that's the case, then it ruins the repair market as well, because with the cost of TVs plummeting and unfortunately their lifespan also shortening, people will just be used to buying TVs and dumping them after a few years like a light bulb and not bothering to repair, and just creating a lot of useless waste. But that's the way the industry is, and I guess as long as they're cheap to make and too expensive to repair, it's going to continue. So there you have it. Hope you enjoyed this video, and as always, thanks for watching. Please leave your comments, and hopefully this will help some of you go ahead and try to troubleshoot and fix your own TVs before dumping them. Thanks again for watching.